Alright, this is part 2 of the Unit 9 review. So let's start at question number 8. So it says the function f of x is equal to x squared plus 2x minus 8. We see the graph over here on the right. And then inside each box for part A, it says for each interval on the box, determine if the graph is increasing or decreasing. So when we talk about increase versus decrease, we always read the graph from the left side going across to the right side. So when it says x is less than -4, we're looking at from -4 on the x-axis, so that's here, and we're looking at anything left of that, so anything on this side. So if we look at the graph, the actual parabola starts up here somewhere, and it's going to be coming down this direction. So when x is less than -4, my graph is decreasing. Because as I move from left to right across the graph, the y values are moving down. Okay, from -4 to -1 on the x-axis, that's from this point. That's from this point to -1, which is at this point. And again, all my values, as I move from left to right, my values are moving down. So again, that's decreasing. And then when x is greater than -1, so -1's right here. Greater than would be anything right of that. Okay, and as I move to the right, I see that my graph is going up, so that is increasing at that point. For part B, it says for each interval in the box, determine if f of x is positive or negative. Remember, f of x just means y. So for each interval, we're looking for what are the actual values of y. So when x is less than -4, again, that's this blue area over here on the left, and everything is above the x-axis over here because my graph is moving this way. So my y values are all positive. Between -4 and +2, -4 is here, +2 is here, so we're looking at the actual y values in that little red box down there, and those are all negative values because they're all below the x-axis. And then when x is greater than 2, that's going to be 2's right here. Greater than 2 is anything bigger than that, so that's over here. And my graph is starting to go up again, so we are above the x-axis, and that is again positive. Moving on to number 9. Dan shoots a basket as shown in the picture. The function h equals -8.5t squared plus 8.5t plus 6 models the height of the ball after t seconds. So for part A, how long is the ball in the air before it hits the basket 9 feet off the ground? Well, 9 feet is a height, and we're looking for how long the ball is in the air. That's a time. So if I go to my function, I'm going to replace my height with 9, so that I get 9 equals 8.5 t squared, sorry, -8.5t squared plus 18.5 t plus 6. And we know from class that in order to solve the quadratic, it has to be equal to 0. So I'm going to move this 9 to the other side by subtracting it. So 0 equals -8.5 t squared plus 18.5 t. And 6 take away 9 is -3. So I have this quadratic that I need to solve. I could use the quadratic formula, but instead I'm going to use my calculator. Let me make that a little bit smaller. So we can actually see everything that's going on. Alright, so I'm going to go to my graph, and I'm going to put in the function -8.5 x squared plus 18.5 x minus 3, and I'm going to graph it, and this is my actual function. Okay, so when I look at this, it's equal to 0 here, and it's equal to 0 again over here on the right. I want to know when is it going to be at 9 feet. So I want to know these times on the left and the right. So we can use our function, menu, analyze graph. We're looking for zeros. I can find this one, and I have a 0 at 0.17 seconds. And I can do it again, and I get another one at 2 seconds. So we have two of them. As Dan shoots a basket. Oops, sorry. How long is the ball in the air before it hits the basket 9 feet off the ground? So it's obviously not going to hit the basket after 0.17 seconds. That's way too soon. So we can say that it hits the basket after 2 seconds. Okay? And we know it hits the basket there because as we see the path of the ball, it's going to hit the height of the basket here, but that's not at the basket. It has to travel and get this way, so it has to be the second time that it hits the 9-second mark. Part B, what is the maximum height the ball reaches? Well, again, I can go back to my graph, but instead of graphing that new function, I'm going to graph the original function. I'm going to clear this one out, and I'm going to put in negative 8.5x squared plus 18.5x plus 6, because we're using the original equation, not the new one, and I want to find the height. So I want to find this maximum height right there. So I can go to menu, analyze graph, maximum, and it looks like my maximum height happens at 1.09 seconds, because that's my x, and the maximum height itself is 16.1. So I come back down to here, the maximum height is 16.1 feet. Then C, what does the domain represent? Well, domain we know is the x value. In this case, x is t. My t value is time. It represents time the ball is in the air. Okay. Go to number 10. Use the information to decide which quadratic function has the smallest maximum value. This quadratic function 1 can be modeled by the equation y equals negative x squared minus 4x plus 5, and function 2 has a maximum at negative 2, 3. So I know the maximum of function 2. I just need to find the maximum of function 1. And the easiest way to do that is to use the calculator. And just need to move it to this side. All right. So again, I'm going to clear my graph out, and I'm going to put in my function negative x squared minus 4x plus 5, and I get this function. So I want to know what that maximum value is. So again, menu, analyze graph, maximum, lower bound, upper bound, and my maximum is at negative 2, 9. So I go over here, my maximum is at negative 2, 9. So which one has the smallest maximum value? I'm looking at the y values. One's 3, one's a 9, so function 2. Smallest maximum. Okay. Number 11. A portion of a graph of a linear function f of x is shown below. An equation of a quadratic function is also shown. So we have a linear function, part of it, and we have a function for a quadratic here that happens to be in vertex form. And then it gives me 3 statements. It says for each statement, use greater than, less than, or equal to describe what's going on. So for the first quantity, so the y-coordinate of the y-intercept of f of x. So the y-intercept is here. That point is at 0, 6, and I need to compare that to the y-intercept of my g function. So there's a couple ways I could do it. I could use the graph, or if it's a y-intercept, that means that x is 0. So if I go over here, I can plug in 0 for x. So I have 0 minus 1 squared plus 5. So g of 0 is equal to negative 1 squared plus 5. G of 0 is equal to negative 1 squared is 1. 1 plus 5 is 6. So this one is 6. This one is also 6. Those are equal to each other. The second one, f of negative 1 and g of negative 1. So f of negative 1 and g of negative 1, that means what is the value of the function? What is the y value of the function when x is negative 1? So for my graph, when x is negative 1, if I follow my graph up, it's going to cross at 7. For my g function, I need to plug in the 1, just like we did for g of 0. So if I plug in a negative 1, I get negative 1 minus 1 squared plus 5. That's going to give me negative 2 squared plus 5. So that's 4 plus 5, which is 9. So this one is at negative 1, 9, where this one was at negative 1, 7. So the g function is greater. And the third one, the maximum value of f of x in the interval 0 to 6 versus the maximum value of g of x in the interval 0 to 6. So from 0 to 6, that's x value, so I'm looking from this point to this point. My greatest value between those is at my y-intercept, so that's at, my greatest value is at 6. For my g of x function, my maximum value is going to be at the vertex. Well, since I'm already in vertex form, remember x minus h squared plus k, I know that my vertex for this function is at positive 1, 5. So this maximum value is 5, this maximum value is 6, so that means my f function is greater. All right, and then the last page, a very similar question being asked. This time we have a graph of a quadratic and a table of a linear function. So we start with the y-coordinate of the y-intercept of f of x. That's going to be here at 0, 0. The y-coordinate of the y-intercept at g of x. So I'm looking for where x is 0. That's going to be this point here. This one is 0. This one is 4. That means g of x is greater. F of negative 1 compared to g of negative 1. Well, f of negative 1, here's x being negative 1. I go up. I'm at 3. For my g function, that's here, negative 1, 3. These two values are the same, so they're equal. And then the maximum value between negative 5 and 0. So negative 5 to 0, that's anything in this range. The maximum value is going to be right here, which is at, it's like negative 2, 4. And for this one, I can infer from this table, since it's linear, that my next point is negative 5, negative 1. So from negative 5 to 0 for the x's, looking at this whole table, my maximum value is 4. So again, those two are going to be equal. And that is going to do it for our review. Make sure you take a look at this and be ready for the test on Monday.